Welcome. How's day 2 going? Good? All right, great. That's a big thumbs up back there. That's good. All right, so this session is called Test Automation with Selenium WebDriver, Java, and JUnit. Instead of coming up with a clever title, I just said exactly what it is. Right? I'll just tell you a little bit about myself. My name is Kito. You can follow me on Twitter at Kito99. I run a little consulting firm where we do training, consulting, mentoring around Java EE technologies, but also around front-end technologies as well. Let's see, what else is there? I'm a Java champion and a Google web developer expert. So I'm kind of straddle both the Java world and the front-end world, front-end web development world as well. And I've spoken at lots of conferences. And over the years, I've been working with web applications pretty much for most of my career, whether it's in Java using Java server faces or some server-side framework, or with a front-end framework, something like web components or even Backbone or Angular, things like that. And so, part of that process has been testing, right? So over the years, I've done a lot of testing. One thing that I've come back to over and over again is Selenium. Okay, so over the years I've worked on projects where we end up using Selenium. I've taught some courses on Selenium and just integration tests and things like that. So that's sort of my core topic for today. So before I start, how many of you write web user interface integration tests currently? Okay, so decent number of you. How many of you have never written one of these things and you're just wondering what they are and why you would write them and how to do it? Okay, how many of you are kind of in between? Okay, so, all right, so this should sort of straddle both areas and give you just an idea about what it's like to write integration tests with Selenium, what WebDriver is, how JUnit fits into the picture, and that whole story, okay? All right, so how many people have heard of Selenium before? I'm assuming that's most of you. Okay, that's good. All right, so just to give you a bit of a background, Selenium was originally developed by Jason Huggins at ThoughtWorks in 2004 and open sourced a year later. So this is dating back pretty far in software development world, right? And it came from a joke that he made about Mercury Interactive, which has some really sort of powerful or theoretically powerful, expensive testing tools. The joke was that you can cure mercury poisoning by taking selenium supplements. So he was not a fan of Mercury Interactive's tools. So that's where the name came from. Apparently it stuck. And there's basically been 3 parts over the years. So there was the Selenium Developer API, there was Selenium Remote Control, and Selenium Grid. So those are sort of the 3 parts, okay? So talk about, well, those were the 3 initial parts. Then there was this other thing called Selenium IDE. And this was developed by Shinya Kasatani in Japan around 2006. And this is sort of a different project, but basically it allowed people not only to write tests using Java, but also to sort of build up tests using a little Firefox plugin. So that was the Selenium IDE project. In 2011, Selenium 2 was released. And this is pretty much the basis of what we are working with now. Okay, so some of the old Selenium APIs and Selenium RC were replaced by the WebDriver API and server. Okay, so when you hear WebDriver, that's also sort of a Selenium project as well. Okay, and usually when you talk about Selenium, you're really talking usually about Selenium WebDriver. Okay. And WebDriver actually became a W3C working draft standard in 2012. So there actually is a WebDriver specification that you can go and look at and see how it's supposed to work and what it's supposed to do. Okay, and Selenium basically is a set of implementations of the WebDriver specification. Okay. So there's Selenium RC, which was it was called RC for remote control. So it was the idea that you could control Selenium or browser instances running on different machines. That was Selenium RC. That was replaced by Selenium Grid. And now there's Selenium WebDriver. So WebDriver has two pieces. It has a client API and a server API. Okay? And the client API is usually what you use to write your tests. And the server API is actually what your test code uses to communicate with a WebDriver instance. Okay? And I think I've got a picture. I'll talk more about that in a minute. And Selenium IDE, again, is that browser plugin that lets you do record and playback, okay? So it's not going to be as cool as some of the really sort of powerful enterprise tools to do record and playback and editing, but it does allow you to quickly do some record and playback of tests. All right, so we'll talk about Selenium IDE first. It's a Firefox and Chrome extension for recording and playback. Until recently, it was only for Firefox, which was kind of annoying. You could basically record tests in Firefox, but you couldn't use it in like any other browser. Now there's actually, basically I think what happened is the new version of Firefox, Firefox Quantum, came out, and it broke all of the plugins for Firefox. And then they're like, oh, I guess we should update Selenium IDE because it kind of stagnated. So the new version works in Chrome and Firefox. Doesn't have as many features as the old version, but it does exist, and it is usable. And basically, you do record and playback. You can record a test, and you can save it in JSON format. Okay. There's a plugin architecture. The old version had a set of plugins you could use. I don't think there's any plugins available for the new version yet. I find it useful for quick and dirty tests and helping you build tests by hand. However, its usefulness is less clear now in the newer version. The old version, you could like record a test and then output it in the programming language of your choice, whether you wanted Java or Ruby or Python or something like that, which is kind of cool because you could use it to sort of get an idea about what test code you wanted to write and then output it and then modify that test in code, right? The new version you can't export right now. So its usefulness is not quite as great. So I'm not going to spend a lot of time on it, but I wanted to give you an idea. There are, though, a few Selenium IDE variants. So if you are interested in this idea of a plugin, a very simple plugin that lets you record tests, there's a few different ones. Cantu, Catalan, Sidex, iMacros. I can't really tell you a lot about how great they are because I have not really used these, but they are out there. And one of them, I think Cantu actually does export in a programming language of your choice. So if you like this model, you might want to look at Cantu and see if you can integrate that with actual tests written in Java or some other language. Okay. All right, so I'll show you very quickly Selenium IDE. All right, so this is Selenium IDE, okay? And you see it's a very, very cute little tool here. Doesn't look like it's doing a whole lot. So what I can do, though, and actually let me kill it. Let me kill this. And we'll go to the, and if you ever go to the Selenium website, it's actually one of the ugliest websites I've ever seen. They have not updated the look and feel in probably over a decade, but it does have decent information. There's also a lot of information on the wiki, the Selenium wiki on GitHub as well. So I've installed this plugin. As I said, it works in Firefox and Chrome, okay? And what I can do is, if I go to a base URL, okay, and then I can hit record, okay, and it's not taking me there, so let me try again with a new project. And let me make sure I close all the other ones so it doesn't get confused. All right. I'm going to hit record. And it's not doing it. It should be popping up a window for me, so I'll just load what I've already got. Simplify things here. All right. So this is a test which I've already recorded. And this is just a very quick test of my website. But you see, basically, it's going through different commands, and it looks like it's failing on some of them. Okay, so it's having an issue with this click command here. Okay, and the way I did this was I basically let me create a new test here. Okay, so that's my new test. Okay. So when I'm recording, you'll see what it's doing is basically for each thing I do, it's recording the actual action here. Okay, and it does it basically picking a default sort of CSS selector. You can also find an element using XPath, or those are pretty much the two main ones: XPath and CSS. Okay, and then what I can do if let's say I select this. Okay. I can verify that text, okay? Now, if I verify something, it's basically not going to kill the whole test if that fails. If I assert something, the whole test will fail, okay? So I like to use verifies because then my test doesn't automatically die, and I can get a collection of the different errors that occurred, okay? So then I'm going to content here. I can verify that this particular element is working, okay? And then I can do the same thing for about us. So this is obviously a very simple test. Okay. So then what I've got here are all of those different operations, okay? So let's see if this works. Oh yeah, okay. All right, so basically we've got a command, and each command takes some parameters, right, and may have a value, okay? So this is basically here it's actually keeping track of where you're going to click, okay? But I could also, if I knew what I wanted to do, I could just insert a new command, and then in that new command, I could just, put in whatever I want, okay? So I could go here and say, okay, I want to add a new command that looks for a title or something, and then I could just put that in there and then move it to the right location. Okay, so you don't have to always record. You can just manually add tests or add steps. And the reason I like to show this first before we get into the actual writing real code is because this sort of gives you an idea about the concept, right? You basically go to a page, you go through different steps, and you can verify different things, right? And when you're working with a web application, a lot of what you have to do is find the element on the page, right? And that can be hard or difficult depending on the application you're working with, okay? So this particular application is using a portal server, and when you use a portal server, you don't have a lot of control over like the IDs of things and stuff like that. It just kind of generates stuff how it wants to, right? So a lot of what you end up doing is finding an element by something which is not always ideal. So, so that home, right? You would like for there to be like an element with an ID equals, menu item 1 or home or something like that, right? But that's not what it is. So sometimes you have to write tests where you actually are looking at the CSS structure or the DOM structure, sort of selecting things sort of based on what you have available, right? So in this case, the selector that it chose, let me go back to that. For the menu, and that is up here. It basically looks for an anchor with a span at a certain location, right? Not necessarily the best way to find something. But you could do some CSS to basically pick the third element in whatever menu or third element in whatever list or something like that. Or if you actually have access to the code, you can work with the developers to make sure that the IDs actually have logical names, or there's a name attribute or something like that, so that you have a predictable test. Because the problem with this approach is that if you don't actually know basically, if anything changes, your test is going to break. And if there's no particular rule about how stuff is structured in the page, it's more likely to break, right? So number one rule, make sure you have some sort of IDs or name attributes on the components that you want to test on your page, okay? So this is Selenium IDE. You can then save your test. It saves it in a JSON file. You can open it. As I mentioned before, if you use a different variation of this plugin, you may be able to export the test and then massage it in Java or a language of your choice, okay? So I find this useful, again, just for quick and dirty tests. I've used it in the past to basically get started with writing tests in Java. But then again, you need the export for that to work, okay? All right, so that's Selenium IDE. Let's go back to Chrome. All right, so then the more interesting thing is really WebDriver itself. And what's great about WebDriver is that since it's a standard, it's really gone a lot beyond just Selenium tests or the name Selenium, right? So basically the idea is that you have a test written in the language of your choice, whether it's Java, Ruby, Python, etc., right? And usually that's going to run inside of some test container, whether it's JUnit in Java or Water with Ruby or whatever sort of test container, right, that knows how to execute the tests, okay? So then that's going to talk via whatever the language bindings that you're using, okay? When you say, hey, grab this element and click on it, right, it sends that request to the WebDriver API. And that goes over the wire to a WebDriver, okay? And a WebDriver is a native executable that talks to the web browser. So it does browser automation. It basically has a way to execute commands natively on that browser, on that operating system, okay? So the benefit of this approach is that you essentially have the ability to really work with the browser without injecting JavaScript, because the older versions of Selenium used to do that. They would inject JavaScript to control the browser, right? But the problem is that really doesn't show how the browser is working, right? Like if you invoke JavaScript to click on an element, that's not the same as, clicking on the element actually with the mouse, right? And the WebDriver API is going to do it in a much closer way. It's basically going to tell the browser, click on that element, okay? So the WebDriver is what is actually driving the browser, okay? And the browser, there are different WebDriver implementations for different browsers, right, and different platforms, right? So there's one for Chrome, IE, Firefox, Android, Safari, etc. Okay? And the nice thing about it is that since they all support the WebDriver API and the WebDriver wire protocol, you can write the same test and have it run against different WebDrivers, right? Which means different browsers. Okay? So that's basically the beauty of WebDriver and how it works. And in this scenario, this might be just running on your local machine, right? You have WebDriver for whatever platform you're using. Maybe, like for example, I'm on a Mac, so I've got like a Chrome WebDriver and Firefox and Safari, right? Locally. But if I want to run this remotely, you can do that as well, and that's where Selenium Grid comes in. Okay. Well, Selenium Grid sort of takes a little bit further, but in general, when you have a WebDriver, you can have a remote WebDriver, which basically takes the calls coming from your client machine and then sends it to WebDrivers on that particular machine, okay? So remote WebDriver is actually a little Java app, and it basically acts as a proxy to point to local WebDriver instances, okay? So this allows you to basically, run your test on remote machines, and that also means that theoretically you can scale that up, right? You can run it on lots of different machines, because even though using this sort of browser automation testing is a good way to sort of at least do smoke tests on your application, if not more complicated integration or functional tests, it's time-consuming, right? They don't always run that fast, so. It's nice to be able to offload that to one or more servers. So the WebDriver interface provides features for most of the common things you would do with working with a web page, right? You can do navigation to different pages. You can set things like cookies, timeouts for waiting. You can handle windows, frames. You can also work with grab elements, do different queries to get elements, like we saw in Selenium IDE, okay? And basically, you have access to this web element. So if you're doing a query to get back, let's say, all the input controls with a name foobar, okay, you get a web element back, and then you can query that, okay? And that basically is an interface to the actual element in the browser, okay? And there's also actions that you can use for more complicated things like mouse and keyboard interactions as well, okay? So the WebDriver API has a spec that you can look at if you want to see more about how it works. There are Java docs for it, so it's pretty well documented. And as I said before, you can use it inside JUnit or test-ng tests. So when it comes to drivers, I mentioned that you can have drivers for like, Chrome, Firefox, etc., right? There's also drivers for Edge. And there's also mobile drivers as well. So you can actually run the same way that you write a test for a desktop app. You can use it for writing against a mobile web application for iOS, Android. I don't really know if Windows Phone is too relevant, or BlackBerry for that matter. But they actually do exist. I don't know if they're really being used, but they exist. And they also have desktop drivers. I haven't actually known of anyone working with these, but they have drivers that actually use the WebDriver protocol for desktop applications as well with Windows or Qt on Linux or Unix. Now, all the drivers I've been talking about before talk to browsers which pop up an actual window, right? But remember, there's also headless browsers. And a headless browser is basically a browser that doesn't actually show you what's going on, right? It just basically does its work, and you can get a screenshot or something, but it's headless. And the beauty of a headless browser is that it usually runs faster. So if you have lots of tests that you're running, a headless browser is going to run faster than a non-headless browser, okay? The drawback is that that headless browser probably is not exactly the same as the real browser. So even though you do tests with the headless browser, it doesn't mean that you're doing the tests inside of Internet Explorer or something like that. Okay. So there's one for HTTP unit. Anyone heard of HTTP unit? It's pretty old, but okay, so a couple of you. So this is sort of a browser it's a headless browser written in Java. That emulates what a browser does, but it's not terribly functionally complete or up to date. So probably not the best choice. Anyone heard of PhantomJS before? Okay, so PhantomJS was probably the first one to really popularize the concept of a headless browser. Okay, but PhantomJS is sort of used to be pretty much the only choice if you wanted a headless browser, but it's pretty much lost. It's not really under active development anymore. And another choice is JBrowserDriver, which I believe is another Java browser. But probably the best choice if you want a headless one is just use Headless Chrome. So pretty much as soon as Headless Chrome came out, PhantomJS kind of died. So you can actually run Chrome in headless mode, which is probably the easiest thing to do if you want to do a headless test. And remember, the main benefit of a headless test is really speed. Okay. So one of the strategies you can employ is to run headless tests very regularly, but then less regularly run tests using the actual browsers, themselves, like Edge and IE and Firefox, etc. Okay. Oh, and I forgot, yeah, Firefox has a headless mode too, I forgot. So you can actually do both of those, which is nice. So we looked at sort of some of the features of the WebDriver API. And there's really nothing here that's new. The only thing that I didn't mention earlier is that you can actually integrate with JavaScript. So sometimes when you're looking at a page, it actually does help to use JavaScript to go a little bit further than what you can do with the WebDriver API. And it's not hard to do that if you need to. Another concept which is really important and sort of a pain when writing WebDriver tests is the notion of waiting. So a lot of times when you write a test, you do something and then you basically have to wait to show that it happened, right? So let's say you go to a new page, you have to wait for the title to change, or you click on a button and you have to wait to get the success message at the top of the page or whatever needs to happen. So that's something that can be a bit tricky, and I'll talk a little bit more about that. Okay. And the main thing to remember is that when you're working with WebDriver, all of the way that tests are organized and things like that are up to the test runner. So here I'll be talking about JUnit and Java, but you can also write WebDriver tests using lots of other languages and frameworks, testing frameworks as well. For Java, the most popular ones would be either TestNG or JUnit, depending on your preference and your team. Okay. I'll be showing JUnit 4, but as you guys know, JUnit 5 is out now, and there is a variation or plugin for JUnit 5 for WebDriver. Okay, so if you're using, is anyone using JUnit 5? I'm just curious. Nobody. One person. All right. I've been wanting to use it as well. So yeah. So if you're using JUnit 5, there is a plugin for WebDriver for that. All right. So what I'm going to do is, if I can increase the font size properly. Yeah, I guess this is not going to increase the font size for me. Okay. All right, so we'll do it the old-fashioned way. All right, so first what I have here is a base class. You, of course, don't have to make one of these, but this is an example one, okay? And you see this is a base WebDriver test. It is a JUnit test, okay? And one of the first things you have to do is prepare the driver, okay? Here's what's happening is we've got a method to prepare the driver, and based on the driver that's selected, whether it's Chrome, Headless Chrome, or Firefox, which is the only things I've written for this test, I am going to, let me see if I can make it even bigger for you guys. I'm basically going to create a new driver, WebDriver instance, and then send in some options. And those options vary by the WebDriver implementation, okay? And if you look at this Chrome path here, okay, this is where I've placed some WebDriver instances. And again, these are native binaries. So basically all I did was I went to the Selenium site and I downloaded the Chrome WebDriver compiled for Mac OS X. Okay, so it's a native executable. So there's that part. And there's also I'll have the driver instance, right? When you clean up, you want to quit the driver, okay? And so this is before class. This is going to be before all of the tests are executed in this particular class, right? And then after class is going to happen after all the tests in this class are finished, okay? So then there's a couple utility methods. There's isElementPresent, isAlertPresent, that just basically use simple Selenium driver methods to determine things, right? There's also, Selenium does have some basic constructs for doing things like working with select dropdowns, okay? So they're not super powerful, but they are useful for at least getting the items from a select element and things like that, okay? There's also a method for working with an alert and getting the text out of the alert box, okay? And then this is always a handy thing. So JUnit has this idea of a rule, okay? So basically creating a rule, and that basically means that I can have this rule, which sort of like an interceptor in like CDI. So I can sort of intercept calls to my tests, right? And basically all this is doing is saying, okay, well, if there's an exception, then take a screenshot, okay? And the screenshot is going to basically use the Selenium API. Basically, there's a take screenshot interface, and it's going to get the screenshot as a file and then save it somewhere, okay? So now if there's an actual failure, I get a screenshot, so then I can look at that later and see what the problem was, okay? So this is my simple base class. Now, let's say what I want to do is just a very simple test for my site. Let's say I just want to do, all right, if I go out of this, okay. So basically, I just want to do a smoke test to just click on some links and make sure it's actually working, okay? Very simple. So I can write a test. Let me pick this one. So this is sort of a home page. And I'm using IT to mean like integration test, because this is not a unit test, right? This is actually more of an integration test. So before I start, I basically am going to get a particular link, okay? I'm going to set some size for the window, all right? And then I'm going to wait a certain amount. And this basically says that whenever I do something, I'm always going to wait at least this long for it to happen, okay? And again, the benefit, like basically the importance of that is that if you do an operation, it doesn't happen instantly, right? It needs to go to a server, it needs to do some processing or something like that. So you want to ensure that your test is waiting a logical amount of time for that operation to occur, okay? So doing this means that any operation is going to it'll wait at least this long. You can also wait explicitly if you want to, if you know something is going to take longer, okay? So here I've got a few tests, one for verifying the home page, one for looking at some different links, okay? All right, and then one, my site uses Liferay, which is a portal server, so this just verifies that Liferay actually is loaded, because if not, then there's going to be a problem, because there's a Liferay object running in the browser, so if that's not there, this decides it's not going to work, okay? So let's say I wanted to run this, okay? So I want to make sure I run the whole thing. Okay. So the good thing about JUnit is that pretty much every Java IDE has great support for it, right? Okay. See, well, went through my tests. Wow, that was exciting. All right. So there, all my tests worked. Okay. So it verified the Liferay loaded, it verified the home page, and it verified the learn more links on the page. Okay. So if we look at the actual tests themselves, okay. So the home page one is basically, first thing it does is it gets the title of the page. It makes sure it contains a string. And what I like to use with JUnit are some of the hamcrest matchers, okay? So if I look at contains string, it's in hamcrest. And these are the matchers you can use in any JUnit test. It doesn't have to be this Selenium test, but it's just very helpful for comparing values in a fluent way, okay? All right, let me go back here. And we were at this one, okay? All right, so basically this is going to get all the titles, and since there's no really smart way, basically we can just say, let me get all of the items by the CSS selector, okay, and then just sort of iterate through. This, of course, means that if they change the order, it's going to fail, right? But also, you could say that part of the contract is that the elements are shown in that order, right? So this is basically just looking to make sure that all of the feature tags are correct, okay? It also takes a screenshot, okay? So if I look here in my target, verify reports. All right, so see there's take screenshot homepage, right? So there's that screenshot, okay? So this is always helpful to sort of validate that your test was running and then, show someone if there's an actual error that occurred, right? So this particular test is always going to take this screenshot, but the other ones may be from a failure. So because of that rule that I had, there is actually a failure already recorded. So there's an error in the test that does the test to contact us page because it can't handle the CAPTCHA, right? So that's something, if you're working with a page that uses that, you'll have to come up with a solution for getting around that if you want to test to submit, maybe a special test mode or something. But this gives you a look at the failures as well. So let me go back here. Okay. So if you look at this verify, learn more links, I get the feature links. I basically am checking to make sure there's the right number. Okay. This again uses a more fluent Hamcrest style syntax with JUnit, which I like. Okay. So this looks for the consulting, training, and other strings. And then also here, you notice you can do navigation easily backwards, and then also you can click on things, etc. Okay. This is an example of an explicit wait. Okay. So here we're not going to worry about that, the implicit wait. We're saying, okay, explicitly we want to wait until an expected condition. Okay. And so basically until the text matches this in particular, we're going to wait. Okay. So you have more flexibility if you're trying to wait a little bit longer for something to happen, okay? And that actually works out well because you're basically saying, okay, I only, I want to ensure that in this test that I'm waiting until this thing occurs. If it times out, if I never get the success message and it's been like, 30 seconds, then that's pretty much a failure, right? That means that either the server died or some code's broken or the web app is having an issue, right? So that would be a failure. Now, I'll show you one more test here, just to give you an idea. So this is the contact form test, okay? Okay, so you saw it very quickly, had a couple of validation errors. And you see there's actually failure here. And what's happening is basically it's looking for a certain number of fields to be on the page, and they're not there. Okay, so expecting to have 2 elements that use this AUI field input, and they're not there. So clearly there's something either wrong with the page or something wrong with my code. Okay. But also you can see here, since we're actually doing input, basically what this is doing, this is actually submitting the form and then checking to see that there are all the error messages that we prefer to see. And there's just an example of how to do it with Java 7 or with Java 8, which of course is a lot more concise, right? But basically what you're doing is you're looking for all the elements on the page and then verifying that they exist or you have the right number of elements, etc. Okay? And then if you're doing input, you basically can get an element, a web element, and then call send keys to send text to it. Okay? And by the same token, if you have an element, you can click on it. Here, I'm creating a new select element and passing in the web element that I've found, okay? And then selecting a value, okay? And then here, I'm clicking on the submit button, but I'm doing it by XPath as opposed to by CSS. So you have a choice of using XPath or CSS for finding elements on the page, okay? All right, so you can basically build up a pretty powerful suite of tests using these basic WebDriver tests. I want to spend just the last few minutes talking about how you can go from something very simple like this to things basically to think about when you're building up more and more tests than just one very simple test. Okay. All right. I should also mention that if you like, how many people like jQuery? How many people use jQuery? All right. The liking is a different story, right? So if you really want to use jQuery to find elements on the page, you can actually do that. And there's a project called Sizzle, which does that, okay? But and actually, in some cases, they will usually want to be injecting jQuery onto the page in order to do what you're trying to do, which may not really work with your application, right? And randomly injecting jQuery may not be a good thing for you. I think Selenium Query actually uses jQuery internally. Jeb does not, okay? So Selenium Query is basically just allows you to use jQuery style syntax, okay? So you can basically find elements in a way that's familiar to you if you're writing jQuery, and it gives you a pretty fluent way to go through operating on elements on the page. So it's kind of a nice way to do things, okay? I don't think I have an example of it, but Jeb is another thing that you might want to look at, especially if you like Groovy. So Jeb lets you write JUnit and Selenium tests using Groovy, and it gives you a very nice syntax and also lets you basically access code using a jQuery style syntax, access elements using a jQuery style syntax, which is nice. Okay. All right, there's also a lift style API that's actually part of Selenium that gives you also sort of a nicer syntax to use. See, I'm saying go to and assert presence of link images, assert presence of at least 4 links with text not equal to images. So another option if you're writing lots of tests to look at to try and make things a little more concise than the pure Java approach. Okay. And of course, you don't have to use Java. If you want to write WebDriver tests, you can use something other than Java. It's just that if you want to use JUnit, you're going to have to use Java. Okay. All right, so a few testing techniques. So what types of tests can you use Selenium and JUnit for? Obviously, one is checking static content. And this is a pretty good use case because static content probably doesn't change quite as much, right? And you can verify that nothing has really changed, that it has all the expected properties. Testing links, functional tests, and unit tests as well. And also just general smoke tests, okay? It's useful for difficult and time-consuming tests, okay? Especially if there's a test that, a manual tester takes them like, a half an hour to do. Automating it might save a lot of time, okay? Smoke testing, again, I mentioned, and I honestly think this is probably one of the best use cases because, one of the biggest caveat with integration testing web applications is that they're fairly brittle, right? If they change the IDs on the page or the order of the elements, that may break a test, right? Or if there are a lot of changes in the requirements and the code is changing often, it's a lot of work to maintain the tests. But if you at the very least maintain a smoke test, you can basically validate that a build actually at least works at, for a happy path case or for some specific cases. So at least you have some assurance that the integrated application works, okay? And of course, like any test, regression tests are great, right? So if you have your happy path test and you just run it again after you make changes, at the very least that no one's broken the happy path, okay? So a few tips. If you're locating elements, searches for IDs and links are really fast. XPath is really flexible, but it can be slower. And I find CSS locators to be a pretty easy way to find things, but that's because I've written a lot of CSS. So DOM locators you can use as well just by looking through the DOM. Sometimes that's helpful. But if you are writing lots of tests, just come up with guidelines that say, okay, use CSS unless there's a case where it doesn't work, or use XPath so that your code is somewhat consistent. Okay. So try and keep your element selectors specific but not brittle. Okay. So some of the ones that are done with Selenium IDE are pretty brittle. So if you were really going to maintain that test, you might want to go back and make sure that the ones that are there are a little more robust, less likely to break. Try and reuse your selectors. So if you have selectors that point to certain elements, especially on a page like a main menu or something, you can factor that out and make it reusable. Okay. There's also something called a UI map or object repository, which allows you to basically put IDs or selectors in a single location. Sometimes it's a configuration file, sometimes it's a class with static constants, okay? It just allows you to kind of put that stuff in one place. So this is an example. So you know that loginform.tb username is basically going to be what that field is called no matter where it is, right? So if you put this in a file and then you load it, you can basically have a way to control the different selectors that are being used in your application. Another key thing is to use the page object pattern. I don't have an example of it. Actually, do I? Yeah, I think I do. All right. So the page object pattern basically gives you an API for your page. so basically what you can do with this is, have operations that you write that encapsulate the functionality of the page so it's easier to test. All right, my time is up. I'll go to the last slide. There we go. All right, so thanks for coming. I will post my session on the Oracle Code site, and if you have any questions, you can hit me up on Twitter or check out my site. Thank you.